दोस्तों, ब्रेनियक आईएएस में आज आपका फिर से स्वागत है। जैसा कि हम आपके लिए ज्योग्राफी की सीरीज लाए थे, ये हमारी क्लास फोर्थ का पार्ट 2 है। क्लास फोर्थ के पार्ट 1 में अपन ने कवर कर लिया था जियोमॉर्फोलॉजी, origin and evolution of Earth and interior of Earth. And in this class, we will cover division of Earth. So let's start our class. And the topic for today's class is division of Earth. Both physical and chemical division of Earth. So that's interesting. Through basics, Earth has core, mantle, crust. Core is the innermost layer, then mantle, then come crust. Crust, uppermost layer of the Earth, interior. Crust is also divided into two: oceanic crust and continental crust. Oceanic crust is below the ocean, and the continental crust. Then there come mantle. Mantle is also divided into upper mantle and lower mantle. Then come core. Let's understand. This is the part of the earth. This is crust. Then come mantle. Then come core. So this is basic division of the earth. Let's understand chemical division of earth. Chemical division. There's two type of division: chemical and physical. First, we understand the chemical division of earth. First, crust. Crust is divided into oceanic crust, continental crust. Crust. We can define it by saying that it is the uppermost layer of the earth interior. Uppermost layer of earth interior, made up of lighter elements such as silica, magnesium, etc. Crust is made up of two: continental crust. First, second is oceanic crust. Let's differentiate both. Continental crust have a average depth of 40 to 50 kilometer, while ocean crust is somewhat 8 to 10 kilometer. Continental crust is thicker, while ocean crust is, that depth is less of ocean crust, so it is thinner. Continental crust is lighter in density. You can understand in future classes this density. It is heavier in density. Density of continental crust is near about 2.7 gram per centimeter cube, while ocean crust density is about 3 gram per centimeter cube. Continental crust is brighter, ocean crust is darker. Continental crust is older in age, while oceanic crust it is as old as 4,600 million years ago. While ocean crust is younger in age, and nowhere you can find ocean crust older than 200 million years, while continental crust is as old as 4,600 million years. Continental crust is mainly made up of silica and aluminium, so it is also called as Sial, while oceanic crust is made up of silica and magnesium, so this is known as Sima. So this is the differentiation between oceanic crust and continental crust. Now let's understand mantle. Mantle extend from crust to up to 2,888 kilometer inside the earth. It is also divided into upper mantle and lower mantle. Mantle is heavier than the crust, but it lighter than the core. Heavier than crust, but lighter than the core. 83% of the Earth by volume and 68% by mass is mental. By volume and 68% by mass is mental. Then let's understand core. Core is also divided into core and inner core. Core is made up of heavier material like nickel, iron. So core is also called layer of knife. That is nickel and ferrous iron. Core is densest of all the layer, densest of all three layers. Density of core is double that of the mantle. Density of the core is nearly 30 gram per centimeter cube. Outer core is in liquid state, while the inner core is solid. This is chemical division of the Earth's interior. Now let's see physical division. We have seen chemical division. Now we should see physical division. Physically, Earth is divided to lithosphere, asthenosphere, mesosphere, and barosphere. This is our Earth. First, there is lithosphere, then asthenosphere, lithosphere, then there come asthenosphere, then mesosphere, and then barosphere. So, what is the lithosphere? Lithosphere. Lithosphere is the uppermost solid layer extending up to a depth of 100 km. Uppermost solid layer to depth of 100 km. This lithosphere is made up of crust plus upper mantle. As you know, crust is maximum 40 to 50 kilometer, 40 to 45 kilometer deep. Lithosphere form crust and upper mantle. It is about 100 kilometer thick. Lithosphere is 100 kilometer thick. Then second is asthenosphere. Asthenosphere extend from about 100 to 400 kilometer. Asthenosphere is a semi-solid and semi-liquid in nature, which undergo deformation under pressure. Semi-solid and semi-liquid in nature. Asthenosphere is also called as low velocity zone because of the slowing down of earthquake waves. Earthquake of low intensity in the interior of the earth not reaches Earth's surface due to its asthenosphere. Nearly every minute there is an earthquake in the Earth interior, but not every earthquake we feel. Earthquake of low magnitude never reaches on the surface, and we didn't feel it because of this layer of asthenosphere. Asthenosphere is a low velocity zone because of slowing. Then there come mesosphere. Mesosphere. Mesosphere extends from 400 kilometer to about 2,888 kilometers. That is up to the crust mesosphere extent, covering covering rest of the mantle perisphere, which is basically core. Paris. This is the physical division of the Earth. First lithosphere, then asthenosphere, then mesosphere, then perisphere. Then we see there are various discontinuity in the Earth's interior. Between these layers, there is discontinuities. So what are these discontinuity? We can define it by saying that it is a transition zone between different layers. It is transition zone between transition zone between different layers of Earth interior. Differing physical and chemical characteristics. These they were differing physical and chemical characteristics. Let's see discontinuity through this diagram. First, there is a chordal discontinuity between upper and lower crust. Then there come Mohorovic discontinuity. This is between lower crust and upper mantle. Lower crust and upper mantle. There is a Mohorovic discontinuity here. Then there come Rapeti discontinuity. It is between upper and lower mantle. And here it is. This is upper mantle. This was lower mantle. Between this is Rapeti discontinuity. Then is Gutenberg's discontinuity. It is between lower mantle and uh, outer core. Of lower mantle and between outer core there is Gutenberg discontinuity. Then last is Lehman discontinuity. It is between outer and inner core. Between outer and inner core, this lies the Lehman discontinuity. Now our next topic is rocks and minerals. First we see what is minerals. Minerals are solid inorganic substance occurring naturally. Solid inorganic substances occurring naturally. While rocks are the while rocks are any naturally occurring agglomeration of minerals, forms a rock. Any naturally occurring agglomeration of minerals forms rocks. What are the difference between these two? Let's see. Minerals have a definite chemical composition, while rocks has no such definite chemical composition. There are four chief minerals: silicates, carbonates, sulfides, and metallic minerals. Silicates, carbonates, sulfides, and metallic minerals. Rocks are divided into three types: igneous, sedimentary, and metamorphic rocks. Let's understand these types of rocks. First type is igneous rock. What are these igneous rocks? Igneous rocks are the rocks formed because of the lava, lava or magma. The rocks which are formed due to the cooling, solidification, crystallization of molten material or magma is known as igneous rocks. They are also called as primary rocks. Rocks formed due to cooling, solidification, and crystallization of molten materials of magma. Igneous rocks are also known as primary rocks because they are the first to form. Other rocks form because of these primary rocks. Igneous rocks are formed directly from the magma. And igneous rocks are of two types: intrusive igneous rocks and extrusive igneous rocks. Uh, First, intrusive. Intrusive simply the rock formed by the cooling of magma below the Earth's surface. Formed due to cooling below the Earth's surface. As the rocks are cooling below the surface, they will cool slowly, slow cooling of magma. This resulted into crystalline structure of rock, crystalline structure of rock. These rocks has higher strength than extrusive rocks, higher strength. है ना? These are also intrusive rocks are acidic, as these rocks have more than 66% of silica. Example: granite, gabbro, and these intrusive rocks are exposed to the surface through various processes like denudation, erosion. Second type of rock is extrusive igneous rocks. Rocks formed due to cooling of magma above the surface, cooling above the surface. As these are cool above the surface, it results into faster cooling of magma, which results into glassy texture of the rocks. These rocks have a glossy texture, and with lower strength. Extrusive rocks are low in strength as compared to intrusive rocks. है ना? Extrusive rocks are basic while intrusive are acidic. They have silica content of about 52%. They are also called as volcanic rocks formed due to volcanic eruptions. Example like andesite, basalt rocks. These are examples of extrusive rocks. This is our first type of the rock, which is igneous rock. Then let's come on second type of the rock, sedimentary rocks. These sedimentary rocks are formed due to the solidification of the sediments of original igneous rocks. Various processes like compaction, cementation, the sediments of original rocks like igneous rocks or same as metamorphic rocks. When these sediments collected in a basin called a sedimentary basin, so these rocks combined together and formed the sedimentary rocks formed by solidification of sediments of original igneous or metamorphic rock. Or another sedimentary rock. Example are sandstone, limestone, clay, chalk, gypsum. These are basically the sedimentary rocks. Let's see the stages of the formation of sedimentary rock. Stages. First stage is weathering, which breakdown of original rock, breakdown of original rocks. Then second stage come after this. When these rocks are break down, then they are transportation by agents like wind, water, etc. Then deposition. This basin where these sedimentary rock deposits called sedimentary basin. Basins basically these are the depressions where this transported rock got deposited and filling the depression and forming a basin type structure. The next process, lithification. Lithification involves conversion of loose sediment into hard rock. Con- this lithification converts these loose sediments into hard rocks. Compaction. In compaction, these sediments are squeezed by the weight of overlying sediments. So, squeezed overlying sediments, squeezed by the weight of overlying sediments. Then cementation, binding together of these sediments. These are the process in the formation of sedimentary rocks. Now let's understand metamorphic rocks. In metamorphic rocks, the form of rocks changes through physical and various chemical process. The rocks form changes. In metamorphic rocks, the chemical composition of the rocks may also changes. Involves change in form of rocks through physical or chemical processes. In chemical processes, composition also changes. Change in pressure condition, it results into dynamic metamorphism. While due to change in temperature condition, it results into thermal metamorphism. Thermal metamorphism. During the process, these rocks arranged in lines and bands called as lineation and foliations. Example of metamorphisms can be limestone. Limestone changes into marble, and then granite. This granite changes into gneiss. This changes into gneiss. Sandstone changes into quartzite. These all are example of metamorphism. Let's understand rock cycle. This we can understand through a diagram. Due to the cooling of magma, it resulted into formation of igneous rocks. And due to the erosion, these igneous rocks breaks into sediments. And due to various processes like compaction or sedimentation, these sediments form sedimentary rocks. Then, due to the change of heat and pressure condition, these sedimentary rocks forms metamorphic rocks. And due to the erosion of these sedimentary rock, it can also form back to sediments. This metamorphic rock can turn into magma if it is buried in the interior of the earth and got melted. So it can turn into magma or can turn into sedimentary rocks. The igneous rocks can also directly turn into metamorphic rocks because of the change in heat and pressure condition. So this is our cycle. There's no cycle that after igneous sedimentary is formed, then after sedimentary metamorphic. These can vary. After igneous metamorphic rocks can also be formed, or sedimentary rocks can be formed. After the formation of sedimentary rocks, it can form metamorphic rocks, or can form back sediments, or due to its burial, can also form magma. So this is rock cycle. So friends, this is for today's class. I hope you find the class productive. Thank you. And if you have doubts or query, you can put them in comment section. I will answer those queries.